Pythagoras word question examples. These are from the textbook, just making sure you've seen these types of questions. A garage is to be built with a skillion roof, that's just a single slope like that, as in the diagram. Calculate the pitch length. A pitch is a slope, so the length of that roof, allowing 500 millimeters each for the eaves. If there was no diagram, of course you'd draw it, and you want to show the triangle. So since you're going to have some different measurements, either mark the triangle or redraw just the right angled triangle. The aim is always, of course, to find a right-angled triangle, either one that will let you get the answer, so this will let me find that distance there, and I'll add 1,000 millimeters in total for the eaves. Or, of course, sometimes the right-angled triangle doesn't give you the length you need, but it will let you find the length you need, so sometimes calculating this. To find this length here of our triangle, it will be 2,800 minus 1,700. So I've got 1,100 millimeters. I've got 2,600. And C is the hypotenuse, and that is the length that we need. Write your formula. Substitute in your values. Oops. Obviously, C is your hypotenuse. C squared is 2,600 squared plus 1,100 squared. Evaluate C squared. Quite a large number. Now, that is C squared. We want C, which is the square root of that. You are okay to leave out one of these lines, but not both. Find the square root. I've totally forgotten where it is on this calculator. Now C is 2,823.1112 millimeters. That is C. It is not the answer. The pitch needs an extra 1,000 millimeters, and you need to show that working. Pitch length equals the measurement we came up with. Now we are going to the nearest the nearest millimeter, and I'm just adding a whole number of millimeters. So at this point we could round if we wanted, or we could leave it in, add 1,000 millimeters, round to the nearest millimeter, and say nearest millimeter. So you're quite clear about what you're finding at any one time. If you're finding C, something in your diagram should be labeled C. A 100-meter radio mast is supported by 6 cables in 2 sets of 3, anchored at an equal distance from the mast. It may help you to look at the diagram in the textbook on this one. It's question 7. The top set of 3 is attached at a point 20 meters below the top of the mast. Each cable in the lower set of 3 is 60 meters long and attached at a height 30 meters above the ground. Find the total length of the cables. Here, and I cannot stress this enough, a 2-dimensional diagram is your friend. Even though it's a 3D situation, you only need to find the length of one of the pairs of cables and then multiply by 3. So here is your radio mast, and in 3 directions out come 2 cables to the same point. So that is, if we looked at one of the pairs of cables, they go like this. And there's 3 sets of those. Here is the ground. And of course, the mast and the ground make a right angle. Keep your diagram as minimalistic as you can. That's all I need, with, of course, some measurements. The top set is 20 meters below the top of the mast, and the bottom set is 30 meters above the ground. This gives me 2 right-angled triangles. This one here and this one here. This triangle is no use to me at all. It's not right-angled. I strongly recommend redrawing the triangles. We have one more piece of information. What is it? The lower set, 60 meters long. So what we want is the 2 cable lengths. I've got this cable length, that's great. I'm going to want this cable length. Do not think I'll use this triangle. Yes, I know this distance. This is a 100-meter radio mast, so okay, this distance in here has to be 50 meters. But this is not a right-angled triangle. This is, and this is. To find this length, you will need to be using this larger triangle. You've got one distance, that's 80. You don't know this, but you can find this distance from the smaller triangle. So your smaller triangle whoops, 60 meters, 30 meters, and B. We're finding B. Write your formula. C squared is A squared plus B squared. Substitute your values. 60 squared is 30 squared plus B squared. B squared is going to be 60 squared minus 30 squared. Evaluate B squared. To 700. So B is the square root of 2,700. 51.96, or just leave it as the square root of 2,700, because you're going to have to do some maths with this number, and you will get a more accurate answer if you keep it in exact form. So keep it in exact form. It's the square root of 2,700 meters. You could simplify this, by the way. We haven't learned about surds yet, but it could be simplified to 10 root 27, or we can take it even further than that. We haven't learned about simplifying surds as far as I recall, so I'm quite okay with you leaving it like that. Now we have the larger triangle. Again, it's not silly to draw a diagram. It is silly not to finish a diagram. This height is 80 meters. We're finding C. This length we just found, it's the square root of 2,700. Substitute, write your formula. C squared is A squared plus B squared. Substitute your values. Now, 80 squared, sorry, I will get some more space happening here. $80 squared plus, now, the square root of 2700 squared. You think about it, if I have the square root of 4, that's 2. If I square the square root of 4, that's 2 squared, which is 4. If I square a square root, I get the number under the root sign. So root 2700 squared is 2700. Much better than putting in 51.9615 squared. Much easier and much more reliable. Evaluate c squared. 80 squared plus, 2700. C squared is 9100. C is the square root of that. 95.39 meters. Then, having found the length of the long cable, you knew the length of the short cable, 3 lots of each. Sorry that I'll have to move over here. So your total length is 3 times 60 plus 3 times 95.39. Now I think we wanted to go to 2 decimal places, so we keep an extra 2 decimal places in our working, so 0.3939. Three times 60 plus 3 times 95.3939. Always keep 2 more decimal places than you want at the end. 466.18 meters. Just have a look at what would have happened if I'd rounded here. We've answered the question, we've got it right. But just if I'd done 3 times 60 plus 3 times 95.39, 466.17. I am out by 0.01. I'm out by a centimetre. Not a huge amount, but just enough that something could go wrong. When I need 2 decimal places in the working, keep at least 2 more, so 4. Keep at least 2 more decimal places than you need in all working.